everybody, Nathan Hall here. It is now quarter four, which is nice. One quarter left. I just want to make sure everyone's a little better at reading and writing than when we started the year. And to that end, we're going to do a lot of reading and writing activities to close us out. Some fiction, some nonfiction. We are starting with nonfiction here. So these are some things we'll go over in live classes. Who reads for fun? What kind of reading activities other teachers give you? What do you like to read? There are goals here. And a big thing we're going to look at is how math applies to nature. One thing we're going to look at, see the sunflower. Kind of pretty, huh? Time of year they're going to start sprouting. So, we have some numbers down here. What do these have to do with the sunflower? Well, that's going to come down to its pattern at the edge and the number of spirals. Believe it or not, these are the best possible formation for them, for the seeds. You cannot do a better one. But check out this pattern. 1, 1, 2, 3, 5, 8, 13. What? What do those have in common? What's the pattern there? Because there is a pattern. And that's what we're going to read about. We're going to read about a story called G is for Google. It's about an Italian mathematician named Fibonacci. He discovered a mysterious pattern that appears all throughout nature. It's a pattern of numbers. So all that math stuff you learned, this is where you start to use it. So we're going to read an informational text. It's all about information and what a pattern is, how that ties back to math. And finally, Google. I'm sure you've used it, but spelled L-E as opposed to O-L. There is a reason for that. First, some vocabulary, architecture, the way houses are built, gradual, slowly, infinity, never ends, numerals, numbers, spirals. That's kind of what we have here. Follow one trail of these. It's spirals, spirals, spirals. Steep. Goes up very sharply. A lot of people got this one with the environmental science lesson. Go over this in a live class, a few more. Constant, all the time. Illustrate, give an example. Sequence. This is Fibonacci sequence. And unique, only one. So, we're going to read about these things. And then I will test your information. How well you understand them. And so one thing you're going to want to do, look at the pictures. Look at the visuals. What am I reading? Why am I reading this? Some questions I'm going to ask. I put these right at the end, right in the beginning, because I'm a big believer that you do need to know these. So what kind of numerals do you want people to use? First 12 numbers of the Fibonacci sequence. What's so special about it? How pine cone illustrates the principle. Let's begin our story. G is for Google. What? We got bunny, we got this, and we got these. What does that mean? So big thing. Used to be we used Roman numerals. Now we use Arabic numerals. That's what these are. They came from the Arabs, believe it or not. So we also looked to the word producer last lesson with economics. Well, producing, making more. So one way to look at it with rabbits. Start with one pair, two bunnies. After 1 month, it's 2, then 4, 3, 5, 8, 13, 15. Fibonacci's numbers again. You always get more. So what is it? It's these two numbers. This number equals this number. This number, this number, this number. So the two numbers before a number added together will equal it. 2 and 3 is 5. 3 and 5 is 8. 5 and 8 is 13. 8 and 13 is 21. 13, 21, 34, and so on. That's the Fibonacci sequence. If you can understand that, you'll see how math applies to nature. Next slide. So this shows up in many other things. The petals of flowers will follow Fibonacci sequence, total numbers. The spirals in a pine cone. So it's usually these will be a Fibonacci number. You count it up, you're probably going to get 21 or 34. These, the spirals of a pine cone, depending on how you count it, will be 8 or 13. So that's a weird thing about it. This sequence always seems to show up in nature. Some are gradual, some are steep. This, the distance here, third rectangle and so on in a seashell, also follows the Fibonacci code, even in a pineapple scales and artichoke's leaves. So these numbers could go all the way to infinity, and they won't because nothing in nature does. So infinity will never end. And so take some time to read this. Be sure you can answer these questions here. So did he invent the sequence? Oh, that's a tricky question. How were these pictures used? And think about nature. Have you ever noticed a pattern that was unique, that you never saw anything like it? And have you ever found anything interesting about numbers in math class? If so, what? Okay, if not, probably won't ask these ones, but be sure you know these questions. They will show up in the assignments and homeworks. And if you don't understand this, come to the live class. Goodbye for now.